Hi, I'm Bezad and I'm a data scientist. Welcome to the module on Python for data science. In this module, we are going to explore Python's incredible data libraries, NumPy and Pandas. Before we get into those libraries, let's look at the module structure first. As a part of this module, I will walk you through hands-on examples that will give you an introduction to the libraries, its main concepts, and the surrounding terminology. By the end of this module, you'll have a foundation to start data analysis using Python. Excited? So am I. Let's start with the NumPy first. NumPy is a Python package which you would find in all sorts of applications, and therefore it's fairly critical that you have an understanding of its fundamentals. NumPy is part of most of the data-related tasks such as data analysis where you would need scientific programming. And as you progress further in the program, even in machine learning, you will bump into NumPy. Pandas, the next inline library that we are going to learn about, is also crucial for data manipulation, exploratory data analysis, and provides us with easy functions for handling large datasets. We'll learn more about Pandas in the next session. That was all for now. See you in the next session, Introduction to NumPy. In the introduction module, I had mentioned that NumPy is extremely popular in many fields of Python landscape. Let's see what is it exactly. NumPy is short for numerical Python. It is used to deal with numbers. All the applications that you would build in Python would deal with numbers in some shape or form. But as someone who had hands-on experience in Python, you may cleverly ask, I can use numbers and do math directly using Python. What's the big deal? That's a brilliant question, and the short answer is that NumPy lets you play with data much faster than the straight Python approach. NumPy leans on the array programming model, which removes the need to loop over your data and speed things up tremendously. NumPy also provides you with a host of numerical functions such as Fourier transformation, matrix multiplication, and etc., which may or may not be of direct use to you, but the libraries that you may use for advanced applications such as deep learning would rely on NumPy for these functionalities. If math isn't your area of interest, don't worry. We are not going to learn mathematics as a part of this module. That was just a short answer to showcase the capabilities of NumPy. You'll get to know the tremendous power of this library and what makes it one of the most important data science library in the upcoming lectures. By now you are aware that Python lists are pretty powerful. A list can hold any type of data and can hold different types of data at the same time. You can change lists, add elements to them, and remove elements from the list. This is wonderful, but one feature is missing, a feature which is very important to data scientists. Analyzing data will often require to carry out a set of operations over the entire collection of the data, and you just want that to be fast. With lists, this is a problem because lists are relatively slow. Let's take a look at this example. We have defined a list of swimmer's height in inches. Let me run this block and just take a look at the values. This is a list which we are familiar with, and the values are 74, 75, and so on and so forth. If you want to convert the heights to centimeters, you have to multiply them by 2.54. Just a factor that you need to multiply a number to convert it from inches to centimeters. And you hope that this call can work, making the calculations element-wise. Let's try that. Let's try multiplying the heights list by 2.54 and run this. Python throws out an error telling you that it cannot multiply sequence by non-int of type float. If you really want to do this with list, What you have to do is to either use a for loop or list comprehension and to go through all the elements of that list one by one and multiply them by that 2.54. This is a pretty inefficient and cumbersome approach. A way more elegant solution to this problem is to use numeric Python, or for short, NumPy. NumPy is an efficient alternative to Python lists. It is pretty similar to lists, but has one additional feature. It can perform calculations over the entire array without needing the programmer to do that. It is really easy and super fast as well. One thing to note is that NumPy does not come pre-installed with Python, so you have to install it yourself using pip install and then import the library. This is how you import the library. You use the word import, it's a legal syntax which we've seen before, NumPy, and you may use a short format for that, np. Once you do that, you can use np and then use all the modules, methods, and functions under NumPy depending on your use case. Let's start by creating a NumPy array. I'm going to call this np heights, and I'm going to use np, and you see if I do so, I can see and hit tab, I can see all the methods that I can use, and I'm going to use array parentheses. Inside the parentheses, I'm going to just paste this list with this square bracket. I'm going to run this, and then I'm just going to look at the values of this np heights. So I have those numbers now in an array, or basically in a NumPy array to be more accurate. And let's just check the type of np heights to make sure that it's a NumPy array. It is a NumPy array. Now let's see if we can do that multiplication by 2.54 over, now this time, np heights. I'm going to write np heights times 2.54, and it's going to return a NumPy array in which each element is 2.54 times the initial array. Basically, NumPy has this feature that it can multiply all the elements in one line of code by a number, and a lot of element-wise approach over the entire array. You should still pay attention that NumPy can do this easily because it's assumed that your NumPy array contains values of a single type. It's either array of list or array of integer or strings. NumPy comes with its own set of methods and operations, as said before. Let's take a look at one example. I'm going to define one list underscore 1, which is just 1, 2, 3, and a second list, which are 4, 5, and 6. And we've seen before that we can merge arrays like this, right? If I do so, I'll get a concatenated version of the two lists, which is 1, 2, 3, 4, and then the second list 4, 5, 6. Now let's try a very similar thing with NumPy. So I'm going to define np1 to be np. Now you know how you define this, right? Parentheses, and let's just have the same list here. Let's do this for the second list and have 4, 5, 6 there. And let's see what would be the result of np1 plus np2. When I run this, I'm going to actually get an array of size 3. And it looks like that each element of the output is just the summation of the elements in the initial two arrays. So I get 5, which is 1 plus 4, 7, which is 2 plus 5, and 9, which is 6 plus 3. So you see that the plus operator behaves differently when you apply that onto list versus when you apply that onto NumPy array. Now let us bring in our arrays from the previous example. We had np heights, and it was an array
of these values, a NumPy array. When we get the type of NP heights, it is telling us that it's a NumPy ND array. ND array stands for n-dimensional arrays. Our array here is a one-dimensional array, and it's perfectly possible to create one-dimensional, two-dimensional, three-dimensional arrays, and so on and so forth.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by upGrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course.